Hello everyone, hope you guys are doing all good. My name is Sammy, and today from my E and GR 251 class, we're going to take a deep dive into what is property tables for thermodynamics. Let's take a deep dive into it. So first of all, in thermodynamics, a property table is a tabulated data set that provides various thermodynamic properties for a particular substance and situation. These tables are essential tools for engineers and for scientists because they can provide a convenient way to look up at the values that describe the state of a system, such as temperature, pressure, volume, and energy. And as you can see here, right next to me, in these kinds of tables, for example, at a specific temperature, I have all the information that I need. I have the specific volume, the internal energy, the enthalpy, and the entropy that I need for my situation. Now, let's take a look at another example. Compute the following property tables for water, and at first it is asked for us for water that's at 300 degrees, and that we know that the internal energy U is 1332 kilojoule per kilogram. And then it is asked for us to find the missing parts, such as the pressure, the quality, and the phase type. And we should remember that phase type are of three. We have saturated, mixture, and superheated. So now you can ask me that it's going to be so complicated to know with only these two information. And I totally agree with you, it's not easy. But, however, I will always recommend to start with the saturated table because it's more easy to read. Because we have a lot of superheated tables. For example, for 300 over here we have internal energy of this number, this number, this number, and goes on and on and on. So by starting with the saturated water table, it's going to help us to first identify if it's even a saturated one. If not, we can look upon the other. For example, here we're on the saturated water table, and we need to look out for 300. So then we go down for temperature, and we found our 300 degrees. Then, by doing so, we need to find the saturated pressure, the pressure that we're looking at forward over here. And here we can find that it's 8.581. So we can mark it over here, 8.581, and this is in megapascal. We need to convert it to kilopascal afterwards. And that the other thing that we know, since we have found it, we have found 300. And how do we know that this is the right 300? Is that by looking so at the internal energy, we found that the internal energy, it is the same. It's 1332. So we know over here that the phase type is saturated liquid. And then the final thing that we need to look for is the X. And we know everything that is not a mixture is 0 or superior to or bigger than 1. So in this case, X is going to be 0. And it's the same thought process that we need to give for all of the other examples and when you're doing your problems. Always write down all the information that you have and then try to find the corresponding information into the table by, first of all, looking at what is the phase type that I'm working with and trying to locate the information that you already have in the table, so then you can find the other missing information that you'll need to solve your problem. So finally, I hope you guys liked the video, and remember, these tables are very important for your whole career in the engineering, mechanical engineering, industrial and aerospace engineering. So make sure to exercise as much as you can on this topic, inshallah. Alright, so take care and see you for the next video.